Welcome to Knowledge Base. One of our fans posted this question as a comment on one of our videos and has asked that we help provide a solution to it, and that's what we're just going to do now. The question says, the adjacent sides of a parallelogram are vector AB equals to 2i minus 2j minus 6k and vector AC equals to I plus 3j minus k. Find the area of the parallelogram. And these are the options to choose from. So we have a parallelogram whose adjacent side is a vector, and we're just going to look for the area of the parallelogram. And this is the area. The area is giving us the the magnitude of the cross product of vector AB and AC, written as AB cross AC or AB times AC, while these two vertical bar lines at either sides of the product gives you the magnitude of the vector, or is the symbol for the magnitude of the vector. So having written that formula, the first thing we want to do is to find the cross product AB and AC. So we write out the vector in a matrix form in this form. So the vector's direction ijk is written in the first row. The second row are the values for vector AB, 2, minus 1, and minus 6. While the third row are the values for vector AC, 1, 3, and minus 1. So this matrix is formed, and we're just going to look for the determinant of this matrix as the cross product of AB and AC. How do we go about that? The first thing we are to assign the signs to each of these columns, and the signs are plus, minus, plus. What this means is we're going to find determinants of this matrix, and we're going to multiply the matrix by the plus sign, the minus sign, and the plus sign for each of these columns. So let's look at how to utilize these signs. So what we do first, we repeat the matrix here, and then we take out the first column and the first row. And when we do that, we are left with this 2 by 2 matrix, and the cross product becomes the 2 by 2 matrix that is left. We form this matrix here, and the point of intersection I will be here. This positive sign is in front here, but we don't need to write it. Having formed this, we continue. We go to the next column, we strike the second column and the first row, and we are left with 2, minus 6, 1, and minus 1. And that becomes 2, minus 6, 1, and minus 1. This negative sign is this negative sign we have here that we have assigned to the second column. The J is the point of intersection. And then we do that for the third column and the first row. So we have a 2 by 2 matrix, 2, minus 2, 1, and 3. And that is 2, minus 2, 1, and 3. Point of intersection is K. We drop the K here. And this positive sign is this positive sign we've assigned. You assign this positive sign like a checkerboard in a checkerboard form, where you have plus, minus, plus in that order, as long as we have the columns in the matrix. Now that we have this, we are going to look for the determinant of this 2 by 2 matrix and multiply them with I, and that will become minus 2 times minus 1. You always start from this diagonal and take the difference of this diagonal and this diagonal. So first is this diagonal, the product, minus 2 times minus 1, minus being the difference, then you take the product of this other diagonal, 3 times minus 6, and then you put your I vector there. The negative sign, you drop it here, and then you do the same thing to this vector. You go this diagonal first, 2 times minus 1, that's what you have here, minus being the difference, 1 times minus 6, 1 times minus 6, and then your J vector, plus, you do the same thing for this third one, 2 times 3, minus 1 times minus 2, 1 times minus 2, and then your K. Now we can simplify this expression further, and that becomes AB cross AC will be equal to minus 2 times minus 1 gives us 2, minus 3 times minus 6 gives us plus 18. That is your I, minus, this is the negative sign here, 2 times minus 1 gives us minus 2, minus 1 times minus 6 gives us plus 6, and then your J comes in, and finally plus 2 times 3 is 6, minus 1 times minus 2 gives us plus 2, and then your K. So simplifying this further, we have AB cross AC equals to 2 plus 18 is 20i, minus 2 plus 6 is 4. With this negative, it becomes minus 4j. 6 plus 2 is 8, and this negative becomes, this positive becomes plus 8k. Now, this is the cross product of vector AB and AC. Now that we've obtained the cross product, the area is simply the magnitude of the cross product written in this form. So we can say that the area is simply the magnitude of the cross product, which will be equal to the magnitude of the result of the cross product we've just obtained. How do we get or determine the magnitude of a vector? The magnitude of the vector is simply the square root of the sum of the squares of each term of the vectors. So we have the square root of the first term here is 20 square, plus the next term here is minus 4 square, plus, and the last term here is 8 square. And by the time we do this with our calculator, we get that the square root will be equals to 20 square is 400, plus minus 4 square is 16, and 8 square is 64. And the square root of this whole stuff will be equals to square root 480 by the time you add all these values together. And so our answer is option B, square root 480 square meters. So this is the area of the parallelogram. I hope you enjoyed this class, and please share your comments in the comment section, your opinion, your thoughts, and please share this video. Thank you very much for watching. See you in our next video. Bye bye.